Hi, everyone. Let's take a look at the following example on page 157, question number 8. Dikembe has reflected the function g of x, which equals to x to the power 3 in the x-axis, vertically compressed it by a factor of 2 over 3, horizontally translated it 13 units to the right, and vertically translated it 13 units down. 3 points on the resulting curve are 11, negative 23 over 3, 13, negative 13, and 15, negative 55 over 3. Determine the original coordinates of these 3 points on g of x. So, of course, step 1 is the self-belief that you can do it. There we go. Step number 2. If you begin with the end in mind, what you're trying to do is you want to write the mapping rule, write down the image, and go back to the original point. So what this means is you want to start with xy. And this is going to map to the following. Now, for your reference, I'm using different colors so you can see what I am referring to here. In this first color, when it's reflected with respect to the x-axis, this means it's going to be negative y. So that's the first transformation. If you look at the next one, vertically compressed by a factor of 2 over 3, this means you have 2 over 3 in front of y. So what you're really doing is you're vertically compressing it by this factor, 2 divided by 3. If you look at the next part, horizontally translated 13 units to the right. So if you go back to the mapping rule, you're going to the right by 13, it's going to be x plus 13. And of course, last but not least, if you think about the vertical translation or vertically translated it 13 units down, you're going to subtract 13 just like that. So once you write down the mapping rule, the difficult part is now over. Step 3, what you're doing is you're going back and you're saying, well, this equals to some of these points. So I'm going to divide this into 3 different columns. So for example, you can say this is the same as 11 and negative 23 over 3. And of course, you can repeat this process for the other 2 points as well. So let's solve one at a time. Anytime you have a coordinate that's equal to each other, what you have to do is make the components the same. So for example, the x components are the same. The y components are also the same. So this implies that 11 equals to x plus 13. X equals to 2. If you follow this idea, you think about negative 23 over 3. This equals to negative 2 over 3y minus 13. Now again, you have to do a little bit of mental math. If you want to grab a calculator, that's perfectly okay. 13 is the same as 13 over 1. So I'm grabbing a common denominator of 3, which means I'm multiplying negative 13 over 1 by 3 over 3, which means you're multiplying it by 1. What that means is you're going to get negative 23, which equals to negative 2y minus 39. So again, notice I'm multiplying both sides by 3. So we can dismiss the common denominator. The opposite of subtracting 39 is to add 39. So on the left-hand side, you have 39 minus 23. That's going to give you 16, which equals to negative 2y. So y is going to be negative 8. So in terms of the first original point, it's going to be 2, negative 8. That's the first one, by the way. We're going to do this 2 more times to find the remaining 2 other original points. So I go back. I hope you're copying it down. If you haven't, you can pause the video. When you're ready, you press play again. I'll be here. Let's keep going. So I'm going to erase some of this. And again, the only difference is I'm going to equate this to the next image. So again, if you go back to the paragraph, the next image that we're focusing on is going to be 13, negative 13. So again, if you go back, let me grab a different color. You're going to equate x with x, y with y, which means 13 equals to x plus 13. And of course, x is going to be 0. Likewise, if you take a look at the y components, negative 13, which equals to negative 2 over 3y minus 13, you can solve for y. First of all, if you add 13 to both sides, that's going to give you 0 on the left-hand side. And of course, if 0 equals to negative 2 over 3y, then y, of course, would be 0, which means the second original point is going to be 0, 0. Now, I would like you to try the third one. And of course, press pause in the video when you're done, and you press play again I'll be here and I'll be happy to take up the last original point. Welcome back. Let's keep going. So again, not to overstate this, I'm repeating the same steps for the third time. So if I go back, I'm looking at 15, negative 55 divided by 3. Again, you want to equate the x components together and the y components together. So you go back, 15 equals to x plus 13, which implies x is going to be 2. If I allowed negative 55 divided by 3, which equals to negative 2 over 3, y minus 13, again, my goal is to solve for y, and I need to multiply the second fraction by 3 divided by 3, which effectively you're multiplying by 1. You're changing the form, not the value. And again, this means negative 55 equals to negative 2y minus 39. The opposite of subtracting 39 is to add 39. So negative 55 plus 39 is going to be negative 16. And of course, if negative 16 equals to negative 2y, then y is going to be 8. So again, the last original point is going to be 2, 8, and those are the three original coordinates of the function g of x. If you find this video meaningful, as adding value to your math life, please consider to comment, like, share, and subscribe. I hope this makes sense.